So in today's lecture, let us see one of the polyalphabetic ciphers, that is nothing but beginner cipher. In beginner cipher, let us take an example of, that is the plain text is given by P1, P2, P3 and C is given by C1, C2, C3 and so on. And in this beginner cipher, one of the important things is nothing but the key string is repetitive. The key string is repetitive. So as we can see here, K1, K2 up to Kn and Ky and so on. So where K is, where M is nothing but it is ranging from its value will be 1 to 26. Its value will be 1 to 26. So and encryption is given by Ci is equal to Pi plus Ki, where Pi is nothing but plain text and K is nothing but key string. Decryption is given by Pi equal to Ci minus Ki. So now let us take an example. If I take an example, keyword as pass and plain text is nothing but she is. So now we can see here the plain text is equal to she is. She is. So now let us take the p values of this. So S corresponds to 18, S corresponds to 18, H corresponds to 7, E corresponds to 4 and so on. So key string will be, again key string is, we have taken p value, keyword is nothing but pass. The pass is nothing but the p values of pass is nothing but 15, 0, 18 and 15, 15 again it is repeated. The only key string has only 3 characters, hence the key string is repeated 15 and 0, 0. So now we need to add 15 and 18 because Ci is equal to Pi plus Ki. We need to add 18 plus 15, that results in 20, that results in 33. 33 more 26 results in 7. So similarly 7 plus 0 results in 7, 18 plus 4 results in 22, 18 plus 15 results in 23 and 18 plus 0 results in 18, all are under mod 26. So now ciphertext will be, corresponding ciphertext will be H and it is H, W, X as well as S. So for the plain text, she is, corresponding ciphertext will be H, W, X, S. So in today's session, let us see how to find out the GCD and multiplicative inverse using extended Euclidean algorithm. So let us take an example to find out the GCD of 2074, 1760. So in order to find out the GCD of 2074 and 1760, so first we need to define several variables like R1, R2, then T1, T2 and then T, and the remainder is called as R and the Q is nothing but quotient. So T is equal to T1 minus Q into T2. So now R1 is equal to 2074, 1760. So if I divide 2074 by 1760, that results in 314 and quotient will be 1. So initially T1 and T2 are initialized to 0 and 1 and T will be equal to, if I calculate, T will be equal to minus 1. So similarly, after that we need to, in the second step, we need to shift the values in towards left by 1 unit. So as a result we will get 1760, 314, 314, again this becomes 1 minus 1. So now if I divide 1760 divided by 314, that results in 190 and the remainder is 190 and the quotient is 5. So similarly, if I calculate this, T is equal to 6. So again similarly, if I repeat the same procedure, so I get the third row as 314, 314, 190, 124, minus 1, 6 and minus 5 and the quotient is 1. Similarly, you repeat the same procedure until you get the R1 is equal to 1, 0. So if I repeat the same procedure, I will get the GCD of 207, 4 and the 1760 will be equal to 2. The multiplicative inverse of the number 1, that is 26, 7. So again the same procedure, using Euclidean algorithm, first we need to define R1, R2, R, Q and T1, T2 and as well as T. T is equal to T1 minus Q into T2 and R1 is equal to 26, R2 is equal to 7, T1 equal to 0 and T2 equal to 1 and T is equal to T. If I calculate, before calculating T, we need to obtain R as well as Q. So 26 divided by 7, results in 5, then q will be equal to 3. So again t will be resulting in minus 3. So again if I shift towards left by 1 unit, it results in 7, 5, as well as this becomes 1, minus 3. So now 7 divided by 5 results in the remainder, which is equal to 2, and the quotient is equal to 1, and t will be equal to 4. So similarly you repeat the procedure until you will get the R1 is equal to 1, until you will get R1 is equal to 1. So at the end I will get the value as the last row will be 1, 0, and it is minus 11, and it is 26. So we need to repeat the procedure until R1 is equal to 1. So now this will be the multiplicative inverse of 26, 7. Since it is negative, we need to add with minus 11 should be added with 26. That results in 15. In today's lecture, let us see how to obtain the ciphertext using Playfair cipher. So in order to obtain the ciphertext, let us consider the key value equal to college and plain text is equal to Sudha. So first the keyword is arranged in terms of 5 cross 5. So you can see here basically the 5 cross 5, the array matrix is 5 cross 5. So the key values are college. So you can see here L is left out. So because it is already appearing in the matrix, so L should be eliminated or it should be omitted. So E, G, and after that A, B, C, D, E. E is already there in the first row, so we are omitting that. F, G, and so on. And I and J are, it is given in the one of the columns. Sorry, one of the block. Then K, M, as well as up to Z. So now plain text Siddhalanga. So you can see here basically we need to divide this into two characters. If I divide this into two characters, that becomes what? SI, DD, and so on. So SI becomes what? So here it is not in the same row as well as same column. So now we need to draw the rectangle in such a way that S as well as I should be included. So S corresponds to Q as well as I corresponds to M. Then after that here you can see here basically DD is there. So now what we need to do? So we need to take one character as well as another character should be filled with the dummy character, which is nothing but X. So here D and X are in the same row. So D and X are in the same column. As a result, we need to take the letter which is below the corresponding that letter. So D corresponds to D. The D for below that letter is nothing but M, and X below the X is nothing but L. So as a result, we have written ML. D and A are not in the same row, but they are in the same column. As a result, we need to take the letter which is right to the D, which is nothing but F, as well as A right to the A is nothing but B, and so on. So again the last character is left with A, the last character is left with A. As a result, that should be filled with the dummy character X, and we can write the ciphertext for this AX is nothing but DB. So overall ciphertext will be this.